This is the first video out of 3 for linear relations, where we're going to be looking at number patterns and determining the rule that goes along with it. So to begin with, we're going to take a look at a couple of patterns, and they're number patterns, ones that you are probably fairly familiar with, and your task will be to determine what the next 4 numbers are. So I'm just going to put them on here, and you may want to hit pause on your video right now, grab a piece of paper, and I'd like you to fill in the next 4 numbers for me. All right, welcome back. So you have been able to take a look at these and determine the next 4 numbers. I usually find that if you just take a look at what's happening between the first 3 numbers, you often can get a bit of a clue. So in this case, you'll notice that it's going up by 3 each time, and because it's going up by the same amount, that's what tells us that this is going to be a linear relation where the pattern itself is changing by the same amount. So we can just keep extending that, and that would tell us that our next number is going to be 11, and then 14, 17, and then 20. And this will actually keep going. We don't actually have to stop after 4, but that'll be enough for us to be able to demonstrate that we understand what the pattern is. So if we take a look at the second one, again, just looking at what's happening as you go from one number to the next. In this case, we're going up by 7 in each case. So we're going to keep that pattern going, and our next one will be 29, 36, 43, and then 50. And then once again, this will continue. For our third one, now this one starts getting a little more interesting because we have negative numbers. So if you have a number line that you could look at, this may be helpful because it'll give you a sense of what's happening. So if you find where negative 12 is and you go to negative 8, this is actually getting bigger. So we are actually increasing or going up by 4 in each of these cases. So at negative 4, when we go up another 4, we're at 0. And then once we hit the positives, it becomes a lot easier to fill those ones in. And then our last one, it does start in the positive range, but you'll notice that it's actually going down by 2. So a linear relation can increase, but it also can decrease. Just it has to be by the same amount each time. And now it's not negative 2, it's actually negative 5. So it's going down by 5 each time. So that means my next number is 2. Then we head off into the negatives, negative 3, negative 8, and negative 13. So if you're able to determine how the pattern is changing, you're already like halfway there in terms of being able to determine the rule. All right, so we're going to take a look at that first one that you had on your page, and we figured out the next 4 numbers. And the key piece here was that you noticed that it went up by 3 each time. So we're going to be using that. That's a really important piece of information. And for us to find a rule is actually going to be an equation that will help us predict all the numbers that are going to be in this pattern. So where we're going to start with this first is we're actually going to put our numbers into a table of values. It'll be helpful later when we go to see what they look like. So we're going to say our first number is 2 from our pattern. The second number is 5. The third number is 8. And the fourth number is 11. Now we could fill them all in. I'm running out of space, so I'll just stop there. And this now connects a number which is going to be referred to as our input number. And we're going to figure out how that input number gets converted or changed into the output number. So the part that you already determined, which was that it increased by 3 each time, is actually a really important part of the rule. It means that our input number had to get multiplied by 3. So when we take a look at this first instance, if I take my first number and I multiply by 3, that gives me a 3, but I actually want to have it end up, this is our output number, and our output or our answer should equal 2. So we have to figure out what kind of math, what we needed to do to 3 to end up at 2. And when you take a look at that on the number line, if we go down 1, that would make a true statement. So that tells us that we would be subtracting 1, and that would give us our output or our answer. Now, the interesting part, we're going to double check that this is actually a good rule here. We're going to check it with our second number. If I take my second number and multiply it by 3 and subtract 1, we get 6 minus 1, which is equal to 5. And that's what we get for the second one. And this rule is really, really powerful because if I keep changing what my input number is, so in this third case, I multiply by 3, this becomes 9 minus 1, which is equal to 8, and that's kind of what I was expecting. So it's a really interesting rule, this one right here, that helps us connect and describe every number that's in this particular pattern. And the really fun part is I could go and ask you what the 20th number is in this pattern, which would mean we'd be adding a whole bunch of extra lines. But instead of actually having to add and add and add, we could just use this rule that just says, well, just take 3 times 20 minus 1. 60 minus 1, oh, that should equal 59. So that means that the 20th number in my pattern is actually equal to 59. All right, so there's the rule. That's what we're looking for. And every linear pattern has a rule that describes how the input and the output numbers connect, or helps describe or determine every number in the pattern itself. All right, so let's take a look at our second one here that you guys have already done. Once again, I just organize it in a chart. I find it easier. My first number is 8. My second number is 15. My third number is 22. And again, you guys identified that this was going up by 7. So again, that gives us the most important part of our rule. It has to be the input number times 7. And then from there, we just have to figure out what else is needed. So again, if I decide to input a 1, my goal is to end up at 8. This is 7, and I'm trying to get to 8. Well, it looks like I'm going to need to add 1. So there we go. 7x plus 1 should equal my output or my answer. And maybe we'll jump down here and check with the 3 just to make sure it actually works, because again, it's supposed to work for every number in our pattern. And this would give me 21 plus 1, which should equal 22. And you'll notice that the 3 is matched up with the 22. So there's the rule for our second one. All right, number 3. Now I am going to fill in my first number is -12, second number is -8. So again, the organization, we're doing the same thing each time. And again, you guys identified that this one was going up by 4. So that tells me that the input has to be multiplied by 4. And again, I like starting with the easiest one. You could use any of these pairs of numbers. I'm multiplying the first number by 4. And from here, I'm needing to figure out how do I get to -12. Well, if I'm at 4 on the number line and I'm trying to get to -12, that means I actually have to go down the number line. So I'm actually going to have to subtract, and this looks like I'm going to need to subtract 16 to get to -12. So my rule should be 4x take away 16. And then once again, I always do a check just to be sure. So I'm going to jump down to my third number in my pattern, and 4 times 3 take away 16. 12 take away 16 is -4, and that's what I was expecting. So I feel really good about this rule and its ability to describe every number in my pattern. All right, the last one that we did, and I said this one was kind of interesting because this was one of the first ones that went down. So my first number is 17, second is 12, third is 7. We've identified that this one is going down by 5. So the way we show going down is it's going to be a -5x instead of a +5x. So that coefficient on the x is going to tell you if it's increasing or decreasing. But past that, we do everything the same. We just look at how the number 1 connects with the 17. So -5 times my input number, and my goal is to get 17. So if I'm at -5 and I'm trying to get to 17, again, a number line would be really helpful here. we need to go from -5 all the way up to +17. The only way that's going to work is if I add 22. So I'm going to add 22, and that should equal my output answer. All right. So again, I'm going to do a check because I think it's really valuable to do that. So -5 times 3, -15 plus 22 is +7, and that's what I was expecting. So again, confirmation that we did find the correct rule for this pattern. All right, so now it is your turn. I am going to ask you to, on your piece of paper, I've got 4 patterns, and I'd like you to find the rule or the equation. So you may want to just hit pause on the video while you work it out, and then come on back when you have finished. All right, welcome back. So in the first example, you will have noticed that this pattern increases by 3 each time. So that means that you took your input number and multiplied everything by 3. And then to end up at the 6, the 9, the 12, and the 15, you did need to add another 3 to the 3x to make sure that you end up with the y value. So the rule for that first one is 3x plus 3. For the second one, this one is going up by 12. So we aren't limited. We can have 2-digit numbers as well. We could even have decimals and fractions. It's going up by 12 each time. So that means that we're multiplying both of those, multiplying the x by 12. And to get to 20, in the first case, we would need to add another 8 to end up at 20. So there's the rule for the second one. Third one is a decreasing pattern. It's decreasing by 2. So again, my coefficient will just be -2 this time because that is showing that it's going down. And I need to add 12 to get to my output. And then the last one, once we get to negatives, again, it's a good idea to take a look at your number line. These are all going down by 1. So our coefficient can be -1x. And we are going to need to subtract 4 to get to our y value. So there are the rules for those first 4. All right, so with that, every linear pattern has an equation or a rule that matches up with it that helps describe and helps us find all the numbers that are in our pattern. Thanks for watching.